In this video, we are going to continue with November 2011, Part A, that is the objective test of the West African Senior School Certificate Exam, Chemistry Paper 2. We are going to continue from question 30 to 50. Before we continue, my gratitude goes to myschoolgist.com for making the question available to us. But if you haven't subscribed to our channel, please like this video, share to other fellow learners, and most importantly, subscribe to our channel so that other papers that we are going to be discussing, you'll be having them. Thank you once more for taking your time to subscribe to our channel. Let's get started. Question number 30. Consider the process represented by the following chemical equation. We have sodium salt, which is solid, dissolved in water. There is an equilibrium there, producing sodium ions, chloride ions, and more of the sodium salt is still left. Now, you should note that in such a solution where you produce ions and some of the solute is still left undissolved in the solvent, or in such a solution where not all the solute is dissolved in the solvent, that is why we will have some ions and some solid left. In such a solution, we will term it a saturated solution. It cannot more dissolve the solid. The solid can no longer dissolve. That's why you see a sodium chloride. A sodium chloride salt still there. That is the solid, and the ions that were dissolved there too. So the equation represents a saturated solution. It represents an unsaturated solution. C, it represents solid dissolving in a solvent. D, fully dissociated solid. The right answer is a saturated solution. A saturated solution. The right answer is a saturated solution. That is a saturated solution. A, 30 is A. Question number 31. Question number 31. Question number 31. Which of the following salt would not be recovered from its solution by heating to dryness? By heating to dryness, which of the salts? If I dissolve sodium chloride, and I heat it in an evaporating dish, I will get back the crystals, the salts. The same thing with potassium sulfate. The same thing with this one. But this one is special. This one is special. You cannot recover. It will not be recovered from its solution. If you do this, B, C, and D, you will recover. But for A, you won't recover. The reason is simple. Let me show you the reason. Okay, let me, sodium carbonate. Sodium carbonate, see what happens with sodium carbonate. When you dissolve sodium carbonate in water, what you are going to have is a sodium hydroxide. It's an alkali that you are going to get, and a carbon dioxide that is going to be released. So we will say that, but your carbon dioxide is going to be released. And what happened? Carbon dioxide is going to escape. The carbon dioxide is going to escape. But others, when heated with water, will otherwise I said others when heated with water will escape as water vapor, and the oppositely charged ions will attract to reform the salt. So this one is going to escape into the atmosphere, and you cannot recover all the salt. Other compounds that I've just listed there, when you heat them with water, the water will escape as water vapor into the atmosphere, and the oppositely charged ions in the salt will attract each other. They'll be attracted to each other to reform the salt. But in this case, it doesn't happen because the carbon dioxide, because part of it has escaped into the atmosphere as a gas. That is why we say sodium carbonate is the only one that will not be recovered from its solution by heating to dryness. Or we put 31 is A. 32, the color of methyl orange in a solution of potassium hydroxide is yellow. Color of methyl orange. The color of methyl orange in a solution of potassium hydroxide is yellow. It's orange. It is pink. It is colorless. Okay, let me show you something here. Say the color of this in potassium hydroxide. Methyl orange. The methyl orange. This is methyl orange. This is it here. This is methyl orange here. It has a pH of 3 to 4.4. This is a methyl orange. This is a methyl orange. It has a coral pink at this pH. Then at the pH of 3 to 4, the pH is cream. But now they said in potassium hydroxide, see, they said the color of methyl orange in a solution of potassium hydroxide. Okay, I said methyl orange with a pH of this. It has a pH of this. That is at 13, 3 to 4. This is the color of methyl orange. This is the color of methyl orange from 3 to 4 is cream. But now methyl orange has to be mixed with potassium hydroxide. Potassium hydroxide is a strong alkali. And being a strong alkali, the pH, the pH is basic. I mean, the pH is above 12. Being a strong alkali, the pH is above 12. So this is going to be the pH of methyl orange in potassium hydroxide. Potassium hydroxide is a strong alkali. It has a pH from 12 right to 14. So it's supposed to be yellow. It's supposed to be yellow here because at a lower pH, these are their color. Methyl orange itself at a pH of 3.4 is cream, but with potassium hydroxide, which is a strong alkali, with a strong alkali, and strong alkali, sodium hydroxide, potassium hydroxide, they have pH of 12 and above. So a mixture of them is going to give what? A mixture is going to give a banana yellow, which is a bright yellow. So if we go back to our question, a combination of them gives, I said a combination of them will give you a bright yellow. So if we go back to our question, so the color of methyl orange in a solution of potassium hydroxide is not going to be orange, it's not going to be pink, it's not going to be colorless, but it's going to be yellow. So A is the right answer. (33) Which of the following factors would not affect the rate of a chemical reaction? Would not affect. Okay. Addition of a catalyst. Are you sure? Addition of a catalyst is going to speed up the rate of a chemical reaction, but we are told would not affect. So catalyst is going to affect. Density of the reactants. What has density of the reactant got to do with the rate of a chemical reaction? That one, B, is question sign. Change in temperature of the reactant. A change in temperature of the reaction, change in temperature is either going to increase or decrease the rate of a reaction. If we increase the temperature, the rate of reaction will increase. If we decrease the temperature, the rate of reaction is going to decrease. So the change of this thing is going to affect the rate of a reaction. The physical state of the reactant. The physical state of the reactant will equally affect the rate of the reaction. For instance, let me say we are using calcium carbonate in lumps, in larger pieces. Calcium carbonate in larger pieces and calcium carbonate that has been ground to powder. The one in powder is going to be, the reaction with the one in powder is going to be faster. It's going to be faster than the one in the larger pieces. First of all, the one in pieces, in powder, there's going to be an increase in the surface area. There are going to be more particles that are going to be involved in collision. So in that case, the only one that is not going to affect the rate of the chemical reaction here is the density of the reactant, which is B. Question number 34. Which of the following quantities represent 965 coulombs of electricity? If one Faraday is equal to 96,500 coulombs. 1 Faraday is equal to 96,500 coulombs. Which of the following quantity represent 965 coulombs? Simple calculation. Come here. Look at the calculation. If one Faraday is equal to 96,500 coulombs of electricity, therefore X Faraday would give us 965 coulombs of electricity, and our value for X is 0.01 Faraday. So 0.01 Faraday is going to give us 965 coulombs of electricity. But it should be remembered that 1 Faraday is equal to 1 mole electricity. 1 Faraday is equal to 1 mole electricity. Therefore, 0.01 Faraday will be equal to 0.01 times Faraday times 1. And how many number of moles are there? It's going to give us 0.01 mole. And if we go back to our answer column, you will see that the number of moles there, the number of moles that we have calculated would be what? The number of moles that we have calculated will be D. And number 35. During the electrolysis of copper sulfate, that is dilute or aqueous copper sulfate. During the electrolysis of aqueous copper sulfate, it is aqueous copper sulfate, using carbon electrodes, the substance produced at the anode is copper solid, is sulfate, is oxygen, is water. Let's do it. Let's see how the system works. Now we have aqueous copper 2 sulfate. We have aqueous copper 2 sulfate. Being aqueous copper 2 sulfate, it means that there is copper in water. So now, when we dissolve copper in water, water is going to produce two ions. The ions are the hydrogen ion and the OH ion. There are two electrodes, the cathode, which is the negative electrode, and the anode, which is the positive electrode. So the hydrogen ion will go but to the cathode. Meanwhile, the OH ion from water will go to what? Will go to the anode. Then, that is for water. Then for copper, for the copper 2 sulfate, for the copper sulfate, we are done with the aqueous. When it involves aqueous or dilute, when they say aqueous sodium chloride, aqueous copper sulfate, or dilute sodium chloride, or dilute copper sulfate. The word aqueous has to do with water. So water has produced two ions that we are done with, hydrogen ion and OH ion, and they have gone to the cathode and the anode. Now it is copper sulfate now. The copper sulfate, when it dissociated or when it dissolves or in water, or when it ionizes in water, is copper 2 ion that is going to be produced, and the sulfate that is going to be produced. The cation and the anion, the copper cation will go to the cathode, while the sulfate anion will go to the anode. Now we have two cations at the cathode and the two anions at the anode. Which one is going to be deposited? The one that is going to be deposited will be based on the electrochemical series. Let's start with the anions under the anode. The one right down at the electrochemical series, will be the one that will be deposited. Look at the OH and the sulfate. Here, the sulfate is more reactive than the OH. So OH is right down at the electrochemical series. The ease of discharge increases. So OH is right down at the electrochemical series. For that purpose, OH is the one that is going to be deposited. That is why I write the OH here with white. Now let's go to the cations at the cathode. Copper and hydrogen ion. If you look at copper and hydrogen ion here, hydrogen ion is right up, and the copper is below it. For that purpose, copper is the one that is going to be deposited. So that's why I write copper there. Our equations are now going to be based on copper and the OH. At the cathode, the copper is going to be reduced. It's going to gain electron to form the copper solid. So this is going to be reduction taking place here from copper 2 to copper 0. So copper solid is going to be deposited at the cathode. Then at the anode, what is going to be produced at the anode will be what? The OH ion is going to give electron that is, in this case, oxidized. It's going to undergo oxidation. It's going to go undergo oxidation. Water is formed, and oxygen is going to be released at the anode. So now our question is, which one is released? Our question now is, during the electrolysis of aqueous copper sulfate using carbon electrode, the substance produced at the anode is, what is the substance produced at the anode? At the anode, the substance that is being produced is oxygen. Oxygen is the one that is going to be released as a gas at the anode. So let's go. Our answer is oxygen. Our answer is oxygen. And if we go there, 35, our answer will be what? C. Now, 36. Which of the following processes does not involve redox reaction? Again, redox reaction has to do with oxidation and reduction. Oxidation and reduction. And oxidation is loss of electron, or an increase in the oxidation number, while reduction is gain of electron, or a decrease in the oxidation number. Let's write this equation and let's see what is happening. This is the equation here. This is the equation here. Quite all right. Look at equation, quite all right. If you look at this equation, quite all right, the decomposition of this, calcium oxide to carbon dioxide. If you calculate the oxidation number for calcium, for carbon, it remains like this. Carbon does not change. Carbon in the reactant and carbon in the product is still, oxidation number is still +4. If you calculate the oxidation number for calcium, calcium does not change. It's still +2, +2. So no change in the oxidation number of carbon and calcium. For that purpose, there's no oxidation that is taking place. For that purpose, we are told which of the following processes for 36, roasting of iron. Roasting of iron, there's redox. Combustion of air, there's redox. Decomposition of limestone. And D, bleaching action of dye. C is the right answer, because under the decomposition of limestone, that is calcium carbonate, there is no oxidation or reduction. So 36 is our answer. I mean, C is our answer. C under 36 is our answer. 37. Which of the following substances is not a reducing agent? A reducing agent. Which of the following substances is not a reducing agent? Yeah, it should be noted that we have nitrogen, ammonia there. We have potassium iodide there. We have hydrogen peroxide there. We have calcium iodide there. So the only one from our studies, you should know that the only one, which of the following is not a reducing agent? All of them are reducing agent. This one is a reducing agent. This one is a reducing agent. This one is a reducing agent. The only one that is not a reducing agent here that we have been using even in the laboratory, and we call it a strong oxidizing agent, is hydrogen peroxide. Hydrogen peroxide is a strong oxidizing agent. That is not a reducing agent. 38. When methane combines with excess chlorine gas in the presence of ultraviolet radiation, the product formed is tetrachloromethane. When methane combines with excess, when it is excess, the word excess, it means that the substitution reaction is going to be occurring. So when an alkane is reacting with a halogen, for example, a chlorine, under UV light, which is acting as a catalyst, there's going to be what we call a substitution reaction. The chlorine is going to be substituting the hydrogen in the alkane until all the hydrogen have been completely substituted. And for the hydrogen to be completely substituted, there must be excess of the halogen. That is why they have mentioned excess chlorine. So if there is excess chlorine, it means that all the halogens are going to be substituted. And if all the hydrogen are all the halogens, all the hydrogens are going to be substituted. And if all the hydrogen in methane are substituted, the product will be a tetrachloromethane. A tetrachloromethane. So when chlorine combines with excess chlorine, once more, if it is not excess, please, we may have only chloromethane. We may have only dichloromethane. But if it is excess, all the hydrogen must be completely substituted. So what they are looking for is the final product of the substitution. So when chlorine combines with excess chlorine, when methane combines with excess chlorine gas in the presence of UV radiation, the product form is tetrachloromethane. Correct. Trichloromethane, dichloromethane, chloromethane, 0. Our product is A. 38 is A. Because all the 38 is A because all the hydrogen have been completely substituted. 39. The IUPAC name of the compound CH3CHOH, then CH2 is this. If you look at this compound here, the compound here is written as, let me write the compound here, that is 39. Let me write the compound here for you to better understand. The compound here, let me see, I can write it here for you. 39 or 39, we have CH 1, 2, 3. There are 3 of them. This is 1, 2, 3. Okay. We have, this is a CH2OH. 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 We are told there is an OH here, and this is a hydrogen. Here, this is hydrogen, hydrogen. This is, you can say this is H. That is CH3. Now, according to the IUPAC nomenclature, we start from here, where the functional, there are 2 functional groups there. I mean, the same functional group is there. So we have, it is 1, it is 2, and this is 3. So in this case, we will say it is, we are going to say that what? The other one is located on the second carbon atom. It is located on the second carbon atom. So if it is located on the second carbon atom, since there are 2 OH groups there on the first and the second, we call it diol. It's a diol. That there are diols there. Now, what do we say? We now say this is 1 to 1 to what? 1, 2. Those are two positions. The first carbon and the second carbon. So we can now say, we can call it, you can call it propane 1,2-diol. Propane 1,2-diol. Then another person may say propan 1,2-diol. Another person might say propan 1,2-diol. But what is recommended for the IUPAC system is not propane. We call it propan 1,2-diol. So it is propan 1,2-diol because it is on the one and on the second. The OH groups are on the first and the second carbon. Then when the two alcohol group, the OH group are, when they are two, we call it diol. If they are three, we call it triols. So in that case, we say propan 1,2-diol. So if we look is that it is propan 1,2-diol, let's look at our equation here. Our answers here, is it propan 2-ol? No. There are two oils, so it cannot do like that. So is it B, propan 1,2-diol? Propan 1,2-diol? Is it propan 2,3-diol? Is it propan 3-ol? So the right answer is propan 1,2-diol. Propan 1,2-diol. So it is B, 1,2-diol. B is 1,2-diol. 40. Which of the following reactions would benzene readily undergo? Benzene will undergo because of the nature of because benzene, as you see, benzene will undergo but addition reaction. Benzene will not undergo polymerization. Benzene is not going to undergo benzene is not going to undergo addition reaction. Addition reaction is under only alkenes will undergo addition reaction. There's high density of electrons in the benzene ring. The high density of electrons in the benzene ring that give rise to the localized system of the benzene ring make benzene open but for substitution reaction. But unsaturated compound, benzene is not an unsaturated compound. Only unsaturated compound will undergo addition reaction. Things like the alkynes and the alkenes, they will undergo addition reaction. But things like benzene, because of the high density of the electrons in the ring, many other substances will want to benefit from the high density of electron. By doing what? By undergoing a substitution reaction with benzene. So benzene will undergo but a substitution reaction, not addition, not polymerization, not hydrolysis. So in that case, benzene will undergo but a substitution reaction. Benzene will undergo but a substitution reaction because of the high electron density in the ring. Number 41. Number 41, a hydrocarbon contains 25% hydrogen. Its empirical formula would be a hydrocarbon. It therefore means that it contains hydrogen and carbon. In order to calculate empirical formula, the first thing we do is it is carbon and hydrogen involved. Now, we are told contains 25% hydrogen. If it contains 25% hydrogen. Then the rest of the percentage, 75%, will go back to what? Will be the carbon. Now, we have been given the relative atomic mass of carbon and hydrogen. Now, relative atomic mass of carbon is 12 and the one of hydrogen is 1. So to have the number of moles, we will divide 75 by 12. We will divide 75 by 12. We will have 6.25. For hydrogen, we'll divide 25 by 1 with 25. Now, at this level, we want the simplest number of moles. The simplest number of moles is we divide all the number of moles by the smallest. And the smallest among them is 6.25. So 6.25 divided by 6.25, we will have 1. 25 divided by 6.25, we will have 4. Our empirical formula for this compound will be CH4. That is methane. In that case, 41 will be CH4. 41 will be CH4. And that is A. 41 will be CH4. 42, a hydrocarbon. 42, a hydrocarbon X was bubbled into an alkane solution of potassium manganate 7. And the solution changed from purple to green. X would likely be an alkene, alcohol, alkanone. It should be remembered for the purpose of revision that in this, the change of color indicates a reaction has taken place, and a change of color from purple to green has shown that a reaction has taken place, and the only hydrocarbon that that this is going to oxidize, because potassium manganate 7 is a strong oxidizing agent, and for that purpose it's a strong oxidizing agent, and for that purpose is going to oxidize a particular hydrocarbon. And in order to oxidize this particular hydrocarbon, the only hydrocarbon that it can oxidize should be a hydrocarbon with a double bond. And that hydrocarbon with a double bond is an alkene. Therefore, alkene will decolorize. We can say alkenes will decolorize potassium manganate solution. It will not decolorize. Alkenes will change the color of potassium manganate for a solution from purple to green. Only alkenes can change the color from purple to green. And in that case, manganese 7 is reduced to manganese 2. So in that case, there's going to be a redox reaction here. The manganese, as being an oxidizing agent, is going to oxidize this hydrocarbon, while itself, the manganese, will be reduced, I think, from plus 7 to plus, I think, to plus 2, something like that. So the only hydrocarbon involved in this reaction here is an alkene. So 42 is alkene. That will be it's a redox reaction. 43. 43. Which of the following formulae cannot be used to represent primary alkanols? CnH2n plus 1OH. That is the formula for alkanols or alcohols. C2H2n plus 2O. So, on this one, let's solve this, and you know which one is a primary. You will definitely know which one is a primary alkanol and which one cannot be used to represent a primary alkanol. Okay. Here, for a primary alkanol, for primary alkanol, the N must be equals to N must be 2. N must be 2 and above. It must start from 2. So A, using the formula that we were given A, if we substitute N as 2, we will have C2H5OH. That is ethanol. And if we do it as a primary alcohol, this is a primary alcohol because what? Because one of the hydrogen have been substituted. Because we are starting from like methanol. Look at it here. That is OH, hydrogen, hydrogen, hydrogen. This is not a primary alcohol. This is not a secondary alcohol. This is not a tertiary alcohol. But now, if we substitute this, if we substitute one of the hydrogens with an alkyl group, let me say methane, CH3. Now this is a primary alcohol, and this is here. So when one of the hydrogen is substituted with an alkyl group, like in this case we have substituted one of the hydrogen with an alkyl group with an alkyl group, which is the methyl group. Now we have ethanol. This is now a primary alcohol. When we substitute another hydrogen here, let me say CH3 again, we will now have 2 hydrogen have been substituted. In this case, we are now going to have but a secondary alcohol. This is going to be a secondary alcohol. And finally, if we substitute the last hydrogen here, 3 of the hydrogen have been substituted. This is a tertiary alcohol. So in this case, or tertiary alkanol, in this case, one of the hydrogen have been substituted in A. So this is a primary alkanol. Now, the second equation, the second formula, if we substitute 2 here, it will be C2H2, 2 times 2 is 2 plus 2 is 6. This is the formula. And if we write the equation, if we write the isomer for this to be this one, it is still the same thing. But remember, please, this isomer, formula here, this is another isomer for it. We call it an ether. This is an ether. Methoxy, methane. Methoxy, ethane. This is an ether. It's an isomer of this. But ethers are not involved. So don't involve it there. We are using only for the one that are alkanols. So now, when we substitute this here, this is a primary alkanol because it has a methyl group. One of the hydrogen has been substituted by a methyl group. Now, with 3, this is the other one that we're given. We're giving it as R prime CHOH. Now, if we draw it, we draw the structure. This is R and R prime. This is carbon COH. One of the hydrogen has been substituted by R. R is a methyl group. R prime means that this one is different from this. This is another methyl group. 2 of the hydrogen have been substituted. This shows that this is a secondary alcohol. It shows that this is a secondary alcohol. Now, so this is not a primary alcohol or a primary alkanol. So D is a D only is ROH. This arrow could be a methyl group. This arrow could be a methyl group. It could be an ethyl group. It could be a propyl group. So this is still a primary alcohol. So the only one that cannot be represented as a primary alkanol or a primary alcohol is C. And that's why we say C is the right answer for this. And our answer for 43, is C. Our answer for 43 is C. 43 is C. Which of the following formulae cannot be used to represent primary alcohol is C. 44. Which of the following pairs of metal constitute soft solder? Soft solder. Remember, as I said, what is a soft solder and what is a hard solder. A soft solder is an alloy of tin and lead. Soft solder is an alloy of tin and lead. In contrast to a hard solder is an alloy of copper and zinc. So that should get into your brain. And now we go to our question. Our question says, which of the following pairs of metal constitute soft solder? Soft solder now would be what? The soft solder now would be lead and copper, no. So sodium and copper, no. Lead and tin, which we just shown there. That is the D is the right answer. Okay, 44 is D. 45. The compound that could be used to remove impurities from hematite in the blast furnace is calcium carbonate. Is calcium carbonate. Is the compound that could be used. The compound that could be used to remove impurities. So, first of all, in the blast furnace, that is when we are extracting the extraction of iron, the impurities there are what we call the silicon dioxide. The impurities there are what we call the silicon dioxide. So in that case, to remove the silicon dioxide, we will need a certain substance, which is calcium oxide. The calcium oxide will react with the silicon dioxide to form what we call the silicate. This is the silicate, and that is the silicate that will remove. And the silicate is calcium SiO3. This is so the compound that will be used to remove the impurity from it is calcium carbonate. Is calcium carbonate. Why I say it is calcium carbonate is because calcium carbonate will decompose to produce calcium oxide that will react with silicon dioxide to remove the impurities. This is it. The impurities is silicon dioxide. So when calcium carbonate dissociates, it will form calcium oxide. This calcium oxide will now react with the silicon dioxide, which is the impurities in the blast furnace. So now the impurities in the ore. So when it reacts, calcium silicate, which is slag, will be produced. So the compound that is being used is this one. So that's why we say calcium carbonate is the right answer. Question number 45 is A. Question number 46. Which of the following compound is used in the manufacture of photographic films? Photographic films. Photographic films, as you know, for photographic films, you should know that we will use something like silver is usually needed. Silver, when silver reacts with chlorine. So for photographic films, this is what happens there in the photographic with it. We will use for the when silver reacts with silver nitrate is with nitric acid, silver nitrate is formed. In solution, the silver nitrate will dissociate to give silver. This silver ion will now react with any of the halide. Any of the halide. It could be with silver chloride. It could be with silver bromide. It could be with silver iodide. So any of the halide is possible. So it is any halide, a silver halide that is being formed will be the compound. So now let's go to our equation. Which of the following compound is used in the manufacture of photographic films? Aluminum chloride. Aluminum chloride is not the answer. Silver chloride, that is right. It must be silver chloride, as we have discussed. So our answer is silver chloride, B. 47. A factor which is not usually considered when citing an industry is nearness to the factor which is not usually considered when trying to locate an industry or try to cite an industry is nearness to source of power. Nearness to source of power. Now, power can come from anywhere. Source of raw material. Raw material can come from anywhere. The market they can export to anywhere. A factor that is not usually considered. This has to do with environmental protection. When people do it in localization of industries, people only look at the source of energy source. People only look at the raw materials, the source of raw material. They only look where are we going to have the market, but they don't take environment into consideration. And one of the environmental issues is residential area. You are citing an industry where people are residing that is going to create pollution, noise pollution, pollution of the atmosphere, gaseous pollution, and all type of things, waste material from the industry. So they don't usually consider the residential area. So that is why it is very, very important to take environmental protection, environmental consideration into environmental consideration into consideration when citing an industry. So the factor that is usually not usually considered is residential area, which is D. Okay, 48. Which of the following methods can be used to separate a mixture of petrol and the liquid paraffin? Petrol and liquid paraffin. Petrol and liquid paraffin. It should be noted that paraffin, or in other words, we can call it kerosene. Paraffin, or in other words, kerosene. Kerosene is, you should know that kerosene is a highly refined, refined and distilled fraction of the petroleum. It contains a lot. Kerosene is somehow oily. It is somehow colorless and somehow transparent. And it should also be noted that it is obtained or it is produced like other petroleum products. It is obtained like any other petroleum product. So a mixture of petrol and paraffin, they are all hydrocarbons that have different boiling points. And the way these are being separated in a fractional distillation column, because the fractional distillation column is arranged in order of the different hydrocarbons with respect to their different boiling points. So the only way petrol and the paraffin are different, they have different boiling points, and they can only be separated using the fractional distillation, because this has different boiling points. So it can be used just by A, fractional distillation. 49. Pollution of rivers by domestic waste causes an increased level of sediments. An increased level of sediments. I say pollution of rivers by domestic waste causes a lot. Domestic waste has to do with what? Wastewater from the kitchen, wastewater from the bathroom, from wastewater, there are a lot, water, drainage from some toilet, drainage from all type of things. Domestic waste. Domestic waste does not have to do with chemical, except something like soapy water and other things like that. So pollution of rivers by domestic waste causes an increased level of sediments. No, 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 no. Increased presence of heavy metals. Heavy metals do not come from domestic activities. Those are from, they can come from maybe mining activities from other industries. But for domestic waste have their own um, um, product that they send out. So it doesn't have to involve heavy metals. C, reduced level of dissolved oxygen. And D, scarcity of nutrients in water. Pollution of rivers. Remember, when all this domestic water they get into the waters, what is going to happen there is there is going to be oxidation taking place within the domestic activities there. The pollution is going to reduce the concentration of dissolved oxygen in it. It's going to reduce the concentration of dissolved oxygen. And this may lead to death of aquatic organisms, the fishes and other ones. So this is the major impact on rivers by domestic waste waters or domestic solid wastes. When they get into water, there's a reduction in the level of dissolved oxygen. So C is the right answer. And 50. 50. 50. Which of the following polymers is thermoplastic? Thermoplastic. Thermoplastic. Perpex, cellulose, bakelite, proteins, thermoplastic. Thermoplastic, we cannot talk of cellulose, we cannot talk of bakelite, we cannot talk of proteins. No. Thermoplastic. Example of other thermoplastics you can imagine. Other example of thermoplastic could be things like polyethylene, polypropylene, PVC, polyvalent chloride, polystyrene. Those are also example of it. Nylon are also example of thermoplastic polymers. Teflon are also example of thermoplastic polymers. Perpex is also an example of thermoplastic polymer. It should be recalled that you might not be versed with Perpex. Perpex is also called the PMMA. Another name for Perpex is PMMA, which is the polymethyl methacrylate. Polymethyl methacrylate or acrylic glass. You can call it an acrylic glass or polymethyl methacrylate. That is another name for Perpex. So all the examples I've given are examples of thermoplastic polymers. Cellulose is not an example of it. Bakelite is not an example of it. And protein is not an example of it. So the right answer for question number 50 is A. That is it. Thank you, listeners, for taking your time to listen to the discussion. As I told you, those of you who haven't subscribed to our channel, please like the video, share to other learners, and most importantly, take some time and subscribe to this channel so that the rest of the West African Senior School Certificate Examination question that we are going to be discussing, you'll be having them. Once more, my gratitude to myschoolgist.com for providing us the paper. Thank you.